This conference will now be recorded.
Okay, so learned this one. We'll go with the next topic. Okay. So before understanding of deep learning, first you need to recall your knowledge, what you learned in machine learning, and we'll compare with what additional things that you will learn. It will be covered in the deep learning. Okay. Why there is a separate topic itself called deep learning? When machine learning is doing everything, then again why we are talking about a word called deep learning? Okay. So here the thing is, let's write machine learning versus deep learning. So whenever the commonality between two classifications is very, very less, okay, in such cases, we will apply machine learning models. Whenever the commonality is very, very high, okay, in such cases, we will apply deep learning models. So that means what here? Commonality is very high. Okay. So what I'm asking? Yeah, you do. Sorry, less. That's my right. Okay. You can prefer any all machine learning models. If your commonality is very high, then you are preferring what? Deep learning models. That is the first thing. So what is will be commonality here? The question is, what is mean by commonality and when should I call as it? Yeah, in which case that you are talking about is commonality. Suppose when you are trying to classify, okay, when you are trying to classify male and female, that means what? You are trying to predict the person is a male or female. So, in generally, you will be able to identify or not with your eyes. The difference, whenever if I show you any difference, I mean any pic, any image, will you able to identify or not whether the person is male or female? Right? So how, because we are well known that how a person male person looks and how a female person looks. Okay, either their dressing style, either their what is it, hairstyle, okay, or the person body type, the clothes, or any other things that persons wears, right? So here it is able to read. That is, you cannot say that. I mean, you are not going to failure to define that who is male and who is female. When I show some image, immediately you will be able to respond. The person is really male or female. So that means what? You have such a clarity, right? That means if I say that the commonality will be very, very less. Commonality will be very, very less. Commonality means here the intersection portion. So what will be the intersection portion here? Like two eyes, one nose, two hands, two legs. Those features will be available with every person, right? Either it is a man or female, a man or men or female, whoever. So it won't be make any difference, right? It is not like that male will have only two hands and female will have only two legs. No, both the people will have. Those are what actually? Those are the commonalities. If I ask you, can you predict me? Yeah, I'll tell you that I will have two legs, I'll have two nose, I'll have 2 ears. Tell me whether I am male or female. So can you tell like that? Because every person will have these things. So those are what here? The commonalities. If I tell that, okay, yeah, I have long hair, okay, I use, I mean, in the sense, someone, okay, yeah, the person has long hair and the person wear so and so lipstick, so and so, what do you say, earrings. So this makes you sense that, yeah, this person is talking about some female person because it is not comes under the commonality. Understanding here the point is, so here we have two different classes, okay, and this is what your commonality. That's why you are able to predict the person is really male or female. So whenever the commonality is very less, then definitely I'll prefer what? A machine learning models. So what are the models that we learned till now in machine learning? Okay, we have logistic, okay, nice base, okay, decision tree. These are the some examples. So these are good if the commonality is up to, okay, it can be used when we have the commonality okay in between classes up to 0 to 40%. That means you can be using this kind of algorithms, yeah, even when you have 0 to 40% of commonality features. If the commonality is very high, it becomes very complex, no? If I ask you, suppose showing a dog face, okay, or dog image, it's not an easy thing to able to identify whether it is a male dog or female dog at one I mean one way of angle. If I give you, okay, if I give you a rabbit face, okay, now it has become very complex to identify. Maybe from the dog features, some of the breeds will make easy and identify that, yeah, whether it is a male dog or female dog. If I go for the rabbit features, okay, and if I ask you to predict that it is a male rabbit or female rabbit, can you able to identify? We cannot, now. The features are very common. So how you are able to predict that it is a male rabbit or female rabbit? So it is not easy at that moment. So in such cases, I need to upgrade with my latest algorithms because the complexity is becoming very high for me, and the most of the common features are almost the same. So how can I decide that it is a male or female? Able to identify what I'm talking? Able to understand? Okay. Now let's go for the next one. There are some other examples where you could see a high commonality little bit. Okay, some other case studies, whichever that we see. If you see the examples what we covered in their past practices, okay, other case studies or any other things. So you might be seen across that some of the examples are not coming a good accuracy. Okay, for the first few algorithms like logistic or Bayes base. If you tried up, you could have seen the algorithm accuracy will be very, very low. That means what? The commonality is very high in such case. So your basic algorithms are failure. That means some other examples may not give an appropriate accuracy. Maybe the accuracy is falling down between 70 to 80. Okay, so in such case, what does it mean? It means commonality is 40 to 60% now. So you are improved. I mean, the commonality is very, very high. So it is not easy to identify that the person is having male or female or diabetic or not diabetic. Understanding what I'm talking? So here now the situation now if I talk about the corona, there is no difference between the person who having a corona and who is not having a corona. Can you able to identify directly? Looking at him? Able to understand what I'm talking? Can you able to identify looking at him directly? I need to have more interaction, no? I need to get investigation. I need to have reports. I need to make tests. After, because you see, you could have already heard about it. Most of the people are already infected with corona, but they are not aware because they are not coming out with the symptoms. They are not getting out the symptoms until unless they made test and they are able to identify that yes, they had influence with the corona. They are also not aware. They are feeling that they are still feel strong. So that means what? The commonality is very, very high between a common person and a corona person. So how to able to predict here? Until unless, right? Able to understand what I'm talking? If it is a disease kind of thing where appearance is getting changed, if it is a disease kind of thing, it is get on a person and the appearance is getting changed, okay, then we can be able to identify that if someone is very, very sick, okay, so for a healthy person, for a sick person, you can easily able to predict. But here the case is different, right? Here the case is different. The person itself is not looks like a sick person. So how can you able to predict that the person is having a corona? That's the issue. That is the biggest challenge. That's why we are in a panic situation that who is having and who is not having, and we are unable to find out. And like that, when we are moving in the market, so from where we are getting, we are also not aware. From where we are facing and we are, where we are taking those virus inside to our body, we are also not. That's why it's using failure. We are unable to trace it. Still, there is no proper indication to tell you that, yeah, who is having exactly, who is not having exactly. That's the issue, right? That's what high complexity, high commonality, right? High commonality. Now here, so this time I made complexity little bit higher. Okay. So here the commonality is very, very higher. So I will use, like now you can imagine that it can, 40 to 60%. Commonality is 40 to 60%. So here we need to prefer your learning method what? support vector machine. Okay, so support vector machine is more easily able to classify than your previous algorithms. Why? Because if you recall your knowledge, we will use a different way of drawing the class. Like we'll use gradient descent, we'll use polynomial. So this makes not with a direct straight line classifier. It will make it will drawing a how you draw in a pencil, that kind of curvature, curvature kind of class, it will do, but it will be successful. Okay. Yes. So yes. Okay. Now this looks better. Further going for the next one. So ML has a limitation sometimes to select the algorithm if the commonality is less than equal or to 60%. That means till now we are talking about 60%. So in such cases, ML algorithm will get failure. Whenever if you see high commonality between your target variable, I mean your classes of your target variable, then you need to enter where. That means whenever if you see high commonality, okay, high commonality, CO commonality in the classes of target variable, okay, then you need to enter into what? Deep learning. Then you need to enter into deep learning. So that means what? Yes, where I am failure in terms of utilizing machine learning concepts. Where I am failure in terms of utilizing machine learning concepts, then I need to take the help of your deep learning. Okay, so here, like that means what? Your commonality is now like this. So what does it mean? Most of the space is under covering in between the intersection part. That most of the space is covering under intersection part, and only few things are left on the remaining actual class 1 and class 2. Right, guys? What I am talking? So in such case, in the below cases, you has to use, okay, neural networks. Okay, neural networks is an algorithm, okay, which comes from the deep learning. Neural networks is an algorithm. Okay, so commonality appears between, so you have to use neural network, which is an algorithm. Okay, so in which case, where you could see 60 to 75%. So still I have not compromised. I'm talking about still if your features are in between 60 to 75%, then you need to prefer this one. All right. Yeah. So as I say, when you are going into deeper, like I say, when you talking about a rabbit, is really cannot able to predict, right? Can you able to predict like that? Can you define that in front of you there is a housefly is moving from your end? Okay. Can you tell that it is a male housefly and female housefly? Right now, it is not easy. You need to catch it first and you need to observe first, right? So that means what? The commonality is like this. So 90% coverage, right now? You can take like that. Yeah, let me write more than 75% of the commonality features. More than 75% of the commonality features. If you see, then you need to prefer what? Deep neural networks. Then you need to use what? Deep neural networks will be used. So that means what? If your training model is your deep neural networks, then the training algorithm is what called? Deep learning. Okay. If your training model, it means train data, test data. If your training data is connecting with neural networks, okay. If your training model is using deep neural networks, then the trained algorithm is called deep learning. Clear? So when to use what? No? Don't worry about what is neural networks here. We'll come to that point. So here I am trying to make you differentiation between your machine learning and your this one. When to use what? If you understand that when to use what, then it will be more easy. Okay? Like that. So when you see the differentiations between two different classes, so how the commonality is getting increases as the way your algorithms also getting increased. So initially, as per the knowledge I have, if you see 50-60 years back, we have only with this linear or logistic regression kind of examples. So with those two things only, everything is predicted. All right. As the time situation grows, they could see a various complexities in the nature. In the nature means what? Situations. Wherever the people who are developing this knowledge, okay, and they could see a various complexities. So in such complexities, he is unable to identify, okay, his learning algorithm is unable to predict the things properly. That means he is getting failure with the previous learnings. So he need to adapt, he need to create a new working algorithms. In such cases, yeah, he is able to identify a support vector machine. Even such cases, in some cases, again, like now before 10-15 years, some cases support vector machine also not get properly, not able to predict it properly. So what happened now? they try to started to understanding, I should have a more what is it, tuned algorithm. I need to create a more tuned algorithm. So they has developed this neural networks. Okay. After that, the people even still not satisfied. Like now in the current situation, like as I said, a perfect example to identify the person is being influenced with corona or not. So you can imagine that what mission to be done, what app kind of preparation to be done, right? Because the appearance here don't make any, what is it, hint, don't give any hint for us to identify the person is having a corona or not. Until unless I need to observe that for some time and how much of breath he is able to take freshly, or is sneezing or what, he is making cough or what, because nowadays cough and sneezing also not coming. Have you observed this one? You observe even nowadays cough and sneeze also not coming out if the person is affected. So internally their organs is getting damaged, specifically lungs. So that means what? I need to identify specifically lungs, observe his lungs through doing test, then only things will come out. So the more complexities become high. In such cases, my neural networks is also be not sufficient. So the most common. So now what happens? As the commonality is very high, complexity is very getting increased, highly increasing. So I need to prefer such other deep neural networks algorithms. So this is. Do you think this will be the end? No idea. No idea. As the situation grows up, okay, as the case studies will come with a new phase, new challenges is coming up in the next 2021 or 2025. In such cases, you may adapt a new learning methods. That is also be possible. That is also be possible. Understanding what I'm talking? Yeah. So come back. So that's how your theory grows. Now try to understand. Now what is your actually a neural networks? So deep learning contains several parts. The first thing that you need to learn, what is actually a neural networks. If you understand what is exactly a neural network, then it will be easier for me to make you understand. Okay. One second. Where did I prepare this notes? Yeah, here it is still. Yes. So it is inspired with from where? Human brain learning system. Why? So how your brain works, how much your brain is taking a complex situations and able to identify before in front of you or wherever. Okay, we are also trying to make such a processor in your computer. That's what. Understanding what I'm talking? Think like now you are actually listening my class. I'm expecting. I don't know whether you are listening or not. I'm expecting that you are actually listening the class. So what other things that you can do in this situation? Tell me frankly, tell me what other situations that you can do along by listening my class. Yes, using mobile. Chetan said, well, correct. Yeah. What other things? Lavi, what happened today? Seems very slow. Yes. Well, Sindhu says that laptop can be handled. Yes, correct. Laptop, mobile. Hope you are not using any pen and paper with you. You are not writing any notes of your own. I asked to write a so many common points whenever I will say here. So that is also making use or not. You are not just listening. You are also required to use pen and paper, no? You are using your mobiles, you are listening, you are observing your laptop, your earphones are in your ears, and you are in your hands there is a pen and book. If someone knocks door at that moment, you will look outside for a moment. Who is knocking door and making disturb me here? If some kids comes to your place, what you will do? Yeah, you will ask them to please move out for some time. We are in busy. If someone, your mother or someone, your father is coming and asks for something, you'll also request them to please, I'm listening in the class, please, we'll talk later. That's how you will respond. So what you are doing, I mean, how many things that you are able to follow here? In a fraction of a second, you are able to use your brain, you are able to use your ears, right? And you are able to use your eyes, your hands, fingers, right? So now what we are thinking is the way, yeah, this is all multitasking. So why can't we make use of this multitasking situation and feed into your computer? So how this actually happens? So in your brain actually, there will be several neurons. Imagine this is a brain, human brain, okay? And this contains several neurons. You might be heard this thing in your 8th class, 7th class textbooks. There is a lot of neurons and cells. Today we are going to a biological class, okay? Yeah, there will be a lot of cells will be there. So this each cell will be connecting with every other cell. This each cells will be connecting with every other cell, and these cells will actively respond and will takes a decision to take, yeah, I mean, what to be done at what time. Understanding what I'm talking? So this each cell will be connected with, not able to see where is my cursor. Yeah. So each cell will be connected with every neuron like this. Each cell or every neuron, however you take, okay? My childhood days, we used to play in games in class. I am able to recollect those things now. Chetan also getting recollected. Yes, like this. So I made only few of the dots here, but actually how many dots will be there? Like that, crores of cells will be there, in fact. So here, each cell is working, connecting with every other cell and take the actively a decision, and spontaneously it will throw it out through your throughout hands or throughout your, if you want to respond through your mouth, you will speak like that. If you want to respond through your hands, you will make some action. Understanding? If you want to respond through legs, you will do something. Understanding? If you want to run out, what happens? Yeah, you will put your earphones and you will start running. So every organ is connecting with your brain, and what actually brain takes the decision, and you will act accordingly. So generally, the persons who are like mentally handicapped, or I mean they got accident, they will get into the coma. What are the situations? Their internal brain cells, it gets damaged. That is what actually. So the brain cells will get damaged and they could not able to identify the people, and they don't connect with their actual organs with their brain cells, and what they think and what they ask to do, they don't make their hands or legs movement. That's what the connection is gets breakdown. That's what happens. So you can imagine that how much that importance this brain is working there, right now. So here also why we are talking about this one here is how actually we are talking how the cells is working here. Similarly, our data points also will create such a neural networks. So this is what here I'm talking indirectly here. These are a network formation is happen. A network formation is happen between several cells. Okay, several cells. So here also we are trying to construct a network architecture in our data points. It's not like that. A simple word I will tell you. Till now, what you learned? Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on. Right? Simply if I tell beta naught, this is what you learn. No? Now tell me this beta 1, beta 2, leave about this intersect for time being. Let's talk about this beta. So this beta 1, beta 2 values will be either same throughout your data, throughout your all the data rows, or it will be a different. Tell me guys. These beta values will be same or different throughout your all 1000 rows or 10,000 rows, whatever. I also like to see what Chetan and Sindhu will tell. Come on guys, respond. So this is the toughest situation, na? What to respond if I say something, what sir will think about me? Come on, Chetan, you should reply. Sindhu? So tell me, come on now, why same? Why same? Why same now? Why will you have the same values? You are forgotten. Why? Because slope will be same now. It's same linear line. Okay. Okay, correct. Somewhat okay. Yes, I agree. So here we will use what actually? Your beta values formula, linear algebra formula, x transpose x whole inverse okay, and x transpose y. This formula will helps us to identify, to create what beta values. These beta values will be same throughout your all data. But what happens in the deep learning, in the neural networks? These beta values will be won't same. For each row, these values will be gets changed. That is the biggest thing. So these beta values will be keeps on changing. Understanding what I'm talking? All right. So here also, so as I say, the more complexity when you are feeling, so I need to understand the situation and I need to construct an architecture. It's not like with line to line. So you says, Chetan says now here, sir, yeah, we'll draw a line. That line will be same for all. Okay. So here, when we are seeing a complex situations, the line is not works out. I need to do something else. I need to do something else here. That's what the meaning. So according to the data points which are spaced in the XY axis, okay, I'm just talking about XY axis. So you are constructing such coefficient values according to the data points which are placed on XY axis or XYZ axis or multi-dimensional angle. Okay, you are constructing a coefficient accordingly. That's what. All right, now come back. So here, yes, human brain will observe and takes the decision according to the situation. So computer processor will follow certain rules. Based on that, it will give result, right? What is the difference? Difference between computer and difference between a human brain here. So human brain will take the challenge as a according to the situation it will take. Computer processor what will do? Yeah, what you learned, what you make learned, it will act accordingly. That means what? If some situation it is facing with a wrong, okay, so computer won't realize those facts. There will be some situation that where it will take a, okay, where it will take a, what do you say, instead of and in identifying the things male or female, maybe it may predict wrong sometimes. But how human brain will think that? So he will start thinking that what are other situations of in identifying that is it really correct or not. So according to the situation he will take that decision, right? So human brain will have a more prediction power than a computer processor. Agree? So here we are trying to put your mind knowledge into your computer. That is what. So why machine learning algorithms failures in such cases? Why? Because it's just working like a computer processor. Now we are trying to put your human brain into your computer process. That's what. So let's try to understand how human brain will work. So here I said what? Human brain will observe and it takes the decision. Observe and takes the decision. So initially, let's imagine if a kid, 3 years kid, okay, he's getting growing now, so he don't know what it is apple, okay. So if I make him show that how, he will touch it, he will feel it, he sense it, he will taste it, he'll observe the color, he'll observe the shape. So these all things makes him understand that this will be called as an apple. If at the next time, now he'll able to ask that, yeah, I need an apple now. Or if I give him a fruit, now he able to identify that the particular thing in his hands will be a what? An apple fruit. Understanding? So that's what, how is that kid's human brain is learning? According to the situation, he is taken some inputs, right? So here also, how we people will learn in generally. Yes, I have made some examples. Look out here. How a human brain will learn. Learn from a teacher. Teacher in the sense here, not me. Anywhere. Okay. So look out when you, as I say, when you are growing as a kid, in between those 10 years or 15 years of your education, there will be several things that will be impacted in your mind from the teacher or not. Knowledge wise. Whatever the explanation that the people gives you, those all things you will get learned in your mind or not. A simple mathematics, a simple social studies, a simple science. How this knowledge are, how did you got this knowledge? How did you got this knowledge? Definitely you should say from the teachers. It's not with the parents. Agree? Parents will make you understand some other theories, some other morals in generally. But where your subject grows? In school only. Right now? Yes. So that is what? One part of your life learning. Next one. Learn from your previous mistakes. Agree? So whenever, say a perfect example, hitting a fruit on the top of a tree from a standing position by you. Once you hit that fruit, you are not able to understand that. Yeah, you are able to understand that at the moment. Yeah, how much pressure is required. So you will realize that, yeah, this is not enough. I need to make more pressure, or I need to control the pressure. So after 5, 6 times, 7 tries, what you will say? You will able to realize that where have you made mistake, and you will perfectly throw it. So this is one also the things. I mean, what? Learning from your mistakes are not. Let's simple example. If you gone through a train without taking the reservation, what happens? You know it. How much of complex situation that you need to face it. No one make you sit properly in any seat. Yeah, you need to be stand sometime. You need to be, if you get seat properly, you may sit, but you can't sleep anywhere. So after completing the journey, how do you feel at the moment? I should not go again for the next time without a proper reservation. For the next time, you won't take the challenge. So it is what? Again, learning things that you is taking from your end or not. That's what, learning your mistakes from this error, right? Yes. Learning from self-experience. Yes, like the way, as I said, yeah, until unless you take the challenge, then only you will get to know. Until unless when you are driving for the first time, when you hit down somewhere or you fall down somewhere, you will be able to realize where you have done the mistake. Right now, where you have done that mistake, you will try to recollect. Yeah, yes, I should not have made a accelerator pressed. I made it more used. I should have controlled the brake. These are the mistakes that you will do in the road. So for the next time, what you will do, you will be controlled. You will take the challenge. You will learn that experience, what you made a mistake, and you will try to control yourself, right? Yeah. And the fourth one is what? Learn from other experience. Very few people will be there learning from other experience. Until unless they don't experience themselves, then only they will learn, right? Very few people will be there learning from others' experience. Instead of, yeah, facing by me, yeah, if someone is facing that problem, so you are also required to learn that experience. Make this one as a fourth one as a best habit. Don't think till you get experience and learn it. Learn from the others what they are observing, what they are talking, what they are teaching, what they are telling. Then you will get a lot of knowledge. And you just not don't just hear it. You should listen it. You need to understand it. You need to, yeah, cautious about your things. Okay. Yeah. So here, by inspiring above things, human powers, our neural network will also get strength. The way how you are learning from your past mistakes and how your human brain is able to realize perfectly. Similarly, your neural networks also gets learned from your previous mistakes. Your neural networks also gets learned from your previous mistakes. Okay, so this is what also called an artificial intelligence. So going forward, we are also doing a similar kind of discussion in your artificial intelligence as well. Okay, so what is the difference? Like if you see that movie robot first part, what do you observe there? The person hero will make a robot there. Okay, so the assistants of the person will ask them, so we will take this one to army. No, he will say, no, I need to test it first. He need to get trained according to the situations first. So what he will do, he will make him sit into the car and he will ask to drive. In some situations, he will move his head left, right, and he will make some exit. So why they are observed there? So still there is some errors are there to rectify it. So he is teaching him now, according to the situations, you need to act accordingly, the way how a human mind is working. So there will be a fire accident, and this person will keeps on running without thinking anything. So that means what, that is a failure again. In such case, human will think another way, but robot thinking is in a, yeah, I given a task, I need to make it clear. That's it. Understanding? So the person again and start thinking that, yeah, this is failure in such cases. I need to make this learning algorithm, I need to make this robot still more strong. So according to the situations, he need to act. So when you made this one more knowledge by making lot of books and reading that, okay, what happens now? The learning algorithm, the robot is gets overtrained by the end. Right now, that is what happened. So the way how your model gets overfitted, and it will throw the lot of errors. So in that situation, Simo movie also, the thing is gets overfitted, and yeah, it will make a lot of wrong things finally by the end. So that is also be possible. So not worry. Now you are still under the learning stage. So yes, here what we need to take from that point is, yeah, learning from the mistakes. So here also learning from the errors what we are getting by the end, and we'll recreate the what, when you will get actually this errors, when you will get actually errors, guys, whenever, okay, your y hat and y values are not same, na? Obviously they don't same, not perfect, but when you will get the errors, whenever the y hat values and y values are not same, this creates what called errors. So why we are getting these errors? Because y hat and y. So that means what, y hat values is not the same exactly of y. So where these y hat values are getting generated, where these y hat values are getting generated actually, that means your beta naught, beta 1, x1 plus beta 2 x2. That means the values what you have taken is not properly given. That's why y hat is somewhere around 1000, my y is around 100. That means I need to realize that what values to be placed in the exactly beta 1, beta 2. If I change the values, what is my observation? Now actually y is 100 and my y hat is 1000, so I need to decrease this value. I need to decrease from 1000 to somewhere. So that's what I got. For the first time I got the error is very high. Let's control that error. So then you asked some time back, long back, now I am getting recollecting. You are asking about the boosting algorithm, right? Now this boosting algorithm is also similar to this. So it is working on the errors. Okay, it is working on the errors and it is changing the values again on your betas. Initially, let's say 25. It's let's say 12. So when it is realized that these coefficients are not proper, so I will change this term again with some other value. Let's see the results. That is what happens. That is how it will work, and it will verify that again the error is now decreased to 700. That means the error is still not proper. It is not still correct. So that means what, he will realize that this error is the beta coefficients what I given at the beginning is still not proper. So again it will change by default with their own values. Not with a random number, with a logical. With a logical thing, it will recalculate the values. Here I am making some randoms, okay? With a logical. Again it will verify how much my error is reduced or now. Understanding? When I change the beta coefficients, my y hat values also gets changed. my y hat values and y are getting more closer, my error will goes down. So when my error goes down, so I will be more happy in generally. But here, yeah, I'm converting into a loop. In all this all situation, I will put into a loop. So this loop will keep on changing the coefficients, weights. In fact, here we'll call as weights, and it will keeps on changing the weights, and it will look for the where you will get the minimum error possibility. Let's imagine you made it to 100 loops, I iteration to 1 to 100, for example. All right, so you could have seen that error that you are able to reduce it by 90th iteration only, okay, with the error as let's say 10. Your y is 100 and your y hat is 110. That means that a minimum error is what here? 10. After 91st iteration, you are still getting the 10. After 92 iteration, you are still getting the 10, because after that you are not able to control your error no more. In such case, your algorithm gets properly trained. You can imagine. This is how this things looks. Learning from the errors. Okay. Yes. Clear what I'm talking till now? So here NN. So I'm going to write this one as NN always, which is called as neural network. Okay, we have still. Okay, so this contains a network of neurons. So yes, as I say here, actually cells is the word that we will use in generally in science. Here we'll call them as brain neurons. Okay, so this contains a network of arrays. Okay, network of neurons. Neurons is a cell of one array. So neuron is one of the element of array. So array is a collection of neurons. Understanding what I'm talking here? What is cell here? An array which contains several cells. That means what? If I take one column or one row, okay, we'll have a several values, one row or one column. So each value is one cell. So here I will call this cell as neuron, one neuron. Okay, so that's why neuron is one of the element of array. Clear? So what is array? Array is a collection of neurons. That means what? Each value from your data set I will be calling as one neuron. Either it's a total row, either it's a total column, I will be calling as one array. Clear? Yes. Yeah, I think the same notes which I told. In a fraction of seconds, my eyes will be observed on all the features availability around me, and it is spontaneously predict the things what was around us and what will inform to your brain. That's what now I'm talking about the how our sense organs will work here. My all sense organs will take the inputs and it will make sense to my brain, and it will tell what action to be taken according to the given situation. All right. So that's what I mean. I theoretically said anyway. So yeah. So let's recollect a linear regression example, and I will connect with your neural networks. How does it work here? So look out here. I'm trying to predict price of based on the size of the house. That means what? Number of bedrooms, 2, 3, 4, 5, like that. How the square feet or whatever the size of the house is getting increased, the price will be increased accordingly. Right now, this is what happens. So what you will do in a general linear regression thing here, you will draw a straight line now, like this, right? This is how you will do. That is what you learn till now. So if I'm talking about this example in a simple neural networks, how does this things appears? How does this thing? So here you are not going to draw this picture like this. the appearance is completely different, not like your person. Okay, so this will be your X and this will be your Y. So this one is a neuron, the values. From X to Y, you are taking the, you are giving this one as one neuron, this X values are neuron, and you are trying to predict Y. Okay, so here neural network will have 3 layers. Neural networks will have 3 layers. What are those? Input layer, hidden layer, output layers. That means each layer contains multiple neurons. So in fact, actually this will be looks like this. If I take an example of X values, so what it is here? Your X. What contains in X? Your age, your height, your weight. So this contains a age which is passing for every person through this value. That's meaning. Okay. So what you are trying to predict here? The person is having, let's say, diabetic or not. Or you think corona, yes or no, that is also possible. Okay. So what are the possible outcomes here? Yes or no. So finally you need to predict what this is. Finally you need to predict this one. So here in your previous machine learning, okay, you are drawing a line like this. So how you are drawing the line? I'm trying to put your linear regression concept in neural networks. Okay, like this. In your regression concepts, you are trying to do like this. So what you are doing here, you will have a beta naught, obviously, for each X value. That means for age, okay, you will add up a beta 1 value and you are multiplying with your X value of your age plus you are multiplying with the beta 2 into your height value plus you are multiplying with beta 3 value into your weight value. And what you are doing there, let's say this is what happens. Again, let me write. Yeah, this is what happens to get your y hat values. To get this y hat values, this is what happens. But here my target variable is the classification. So what we will do? What you will do, guys? In logistic regression, specifically, we'll apply logistic function. That means what? You are adding another function on your things what you calculated. You are adding a function on the things what you are calculated. So this is what here we'll call them as what? Activation functions. This is summation, the first step that you are doing, and here you are doing an activation function. Hope you remember the logistic function. Remember now? Or forgotten? So what applying exponential, correct? E power beta x divided by 1 plus e power beta x. That is what a logistic function that we have done. So I'm trying to put your linear regression, logistic regression curve in terms of neural network. This is how does it appears. Now, as my complexity, as I said, my dataset complexity grows higher. So here this will be called as what? Input layer. And this is what it will be called as here? Output layer. So in between input and output layer, in neural networks, we'll construct a new layer called hidden layer. We'll construct a new layer called hidden layer. So directly it won't give a y hat values. You will reconstruct a line. In that line, it will calculate again a neurons. It will calculate a neurons in between your input and output. Okay. So that means what? My input gives an output. That output will called as hidden layer. Okay. My output, which is called as hidden layer, will become again an input, and it will reconstruct the values, and it gives a output layer. That means what? For hidden layer, what is your input here? Input layer. For output layer, what is your input here? Hidden layer. Understanding? So I think we have a lot of here. So let me explain here a little bit. Yes, that means each layer contains multiple neurons. Yes. Why? Because why I'm calling as multiple neurons? Because I'm talking about one respective ID. One ID. That means first person's information. But in oral data, how many rows will you have? If I take 1000 rows, so that means what? For 1000 times it will pass those values, right? Every time, first row, first person's age, first person's height, first person's weight will do, and it will recalculate and it will put the overhead. Second person, again, second person information will be passed out here. Again, it will recalculate and it will predict the results. Third person, like that. So how many neurons will be? More number of. So input layer will be take the data from the source and it pass that input along with the weights to next layer. Understand what it is mentioned here? Input layer will take the data from the source and it passes that input along with weights to next layer. So here there will be some mathematics will be happens. Dot product of input matrix and weight matrix will be sent to the next layer. So what it will be that we'll see in tomorrow's class. We won't understand. Now I have to put up some mathematics again. Okay. Yeah. So I think let's stop for today. Till now your things are clear, guys. We need to do 1 or 2 days more theoretical discussion. Then I'll go with the practical. If you understand this, the importance when to where and how to apply and how this construction is happened, then only this makes a clear understanding how deep learning will works. All right, I cannot jump directly with the code here. You won't get what is happening. All right, so we'll do one thing. We'll stop for today. We'll continue this session. You are going for more biological question, like nervous system contains neurons cells, okay, to transmit information to nerve cells. I cannot say yes or no. I'm not much good in science. I forgotten the science actually. Okay, so you can imagine like that. All right. Okay then. So let's stop for today. We'll meet up in tomorrow's class. Okay. Bye guys. Yeah, input, hidden, output. I said yes, correct. Yes, you are right. Understanding is correct. Okay. Done.